Okay, so this is a whole different unit to the stuff that we have been doing up to now. So there isn't any stretch factors in here. There's no equations and graphing and all that. So we will get back to that soon. We're going to take a little break here. Now, this whole unit is about how many options are there. Okay? There are two types of how many options are there, and there's permutations or combinations. Now, we're going to go into detail on both of these a lot later, but for permutations, okay, order matters, okay? For combinations, order doesn't matter. Okay, that's always true. So you're going to get to the point whenever you're asked a question, you have to ask yourself, is this a perm or is this a com? Yeah, order matters, so it's a perm. Now, what does this mean? What I'm saying is if I gave you, or one of your fellow students gave you the three numbers of their combination log, would the order you put them in matter? Yes. So is it a combination log? No. You've been misled your whole life. They're actually permutation logs, okay? Now, where would order not matter? Or if I just gave you the three things, you'd be good to go. Addition, multiplication, very good. Order doesn't matter if you're adding three numbers and you mix up the order. Okay? But division and subtraction, order does matter a lot, right? Now, when you're ordering a pizza, would that be a permutation or a combination? Combination. Would you say ham and pineapple, hang up the phone, go, oh crap, I meant pineapple and ham. And they're like, whew, okay, good. Good call, because we're just going to put it in the oven, so that's good. We can change that. Okay? Now, when you're making a pizza, does order matter? It would be gross if the, like, tomato sauce is on the top, right? It all looks the same later. It turns into a combination, but it starts as a permutation. Okay? Get your imagination going now. So, the challenge of this unit will be reading the question, deciding is it a permutation, is it a combination, getting all the restrictions, dealing with all the restrictions, and then doing a question. Okay? So I'll give you an example of how you can do a permutation question. There's 6 people in your family, and the photographer says, just line up in one line, and I'll take a picture. Now, does order matter for how that picture looks? Yep, because it's a different picture if you change the people, right? So I could say, just stand in a line. But I could say, you've got to be, say there's equal number, or, how do I say this? There's a same or one less number of males, females in your family, and the photographer says, okay, can you line up boy, girl, boy, girl? So, do you see how I've changed it already by saying it has to be boy, girl, boy, girl? Now the permutation is different. What if I add in, oh yeah, and Jane and John, they can't stand beside each other because they always fight. So make sure they're at opposite ends. So I need opposite ends, I need boy, girl, boy, girl. So everything changes in the question when you do that. So you'll figure out with perms and coms, it is one of those units where you need it quiet. You need to be thinking. You need to be, when you're in the gym and you're trying to do one of these and someone's chewing gum beside you and someone's got, like, their nose is running and someone's got a wrapper going and you're trying to concentrate on these, you will find that these will be the 4 quickest questions on the diploma, but or fast to do, but will take the most thought. Okay? Because when they just say, okay, Joe's shopping for a car, there's 3 different models, and for each one there's 5 different colors, how many different cars could there be? Done. So they're very fast. To do them right or do them wrong, they're extremely fast. Okay, you'll see when I hand out the quizzes, you'll see that as the first person sits down to the last person, that first person will be done before that last person sits down. They're very quick. The quizzes will go quick for the next. That doesn't mean that first person got any of them right, but they're fast. You'll do them wrong, it's fast. Okay, there's no secret in your calculator to find them. It's all going to be thought. Word problems. Everybody loves words, right, in math? And a lot of curves thrown in there to be able to just mess with your head. Okay? Now, we're going to start off with the simplest of all of the units, and that is the fundamental counting principle. And fundamental, I think that's pretty self-explanatory. That's like the foundation. You got to know this, or else the rest is not going to go well. Graham, you with me there? Now, here is an example of how we do what is called a tree diagram, okay? Now, if you have Joe here and he's shopping for a car, the dealer says there is 3 different models and that each model has 5 different colors. So here you have model 1. Now we call this stage 1. And in stage 2, we're going to put the color. So there's blue, red, white, black, okay? Now, is model 1 in blue unique to model 1 in red? Yes, they are, okay? Color is extremely valuable to people, okay? Now, if you're looking for like an old crappy truck because you're renovating your house and you need a truck for like the next 2 months, so you're just going to buy anything that's a truck, probably you couldn't care about the color, okay? But if you're at the car lot and this is your first brand new car, you're out of university, you want this to be nice, you want, and they got 5 different colors there, you will pick the color you like the best. Okay? When Henry Ford first started making the Model T, there was a slogan that you can have any color you want as long as it's black. That was his slogan. And if you look, Model Ts are only black. I mean, you can paint them now, obviously, but anyone that ever came, and that's how he was able to just keep producing them like crazy. Okay? They didn't have, like nowadays, it's nuts. Like you can almost just put into the computer what color to make, and it goes through, I don't know if you've ever seen a car painted, but it just goes through all these things, little robots hit it, comes out, bakes, it's good to go, right? It's as easy as pressing a button. Where back when you're first doing it, I mean, everything was done by hand, right? So, obviously the choices were limited, and it kept things cheap, okay? The other thing, style of the vehicles. Style of the vehicles now can change every year because it can all be done with the computer now and the way the molds are made. Back, even 20 years from now, cars stayed the same for like 10 years because retooling, they called it, was very expensive, right? Nowadays, you can almost have a car that's 2 years old, very different than the new one coming out. Same model, it's 2 years from now, and they've changed this, they've changed the sides a bit, right? And, it is to the point that now they can retool very cheaply because of the way, but retooling was very expensive, and in fact, when, you retool to make a vehicle, like the Jeep Cherokee was one of them for like 13 years, it did not change at all, okay? To the point where they were making almost 100% profit at the end when Jeep Cherokees were coming off because they'd paid for themselves already. Okay, because they actually put in that, when they first started Jeep, they're a bit more expensive because they got to cover all that retooling cost. After a while, they had so much money that was built into the markup there. At the end, it was, already paid for by the people at the beginning. So having each one of these, and let's face it, color is not the only option. You can get with leather, without leather. Now there's even more different choices out there. You can get with air conditioning, without air conditioning. Then you're on to the next. You can get nav or no nav, right? I mean, it just goes on and on and on. So each one would be a different stage. Okay? Now, you can see here in stage 1, there is 3 different options. In stage 2, there was 5 different options per. And how many different models does that make? 15. So do you see a faster way that you could come to this? Just go first stage times second stage and you will get the answer. Now, we're going to do one of these because a tree diagram could be asked of you on a written response question by me. So here's just a wooden toy, and it's made in 3 parts. You've got a top part, which would be red, white, blue, or pink. Then there's a middle to that wooden toy. You could either have orange, purple, or black. And part 3, the bottom could be yellow or green. Okay, so in stage 1, we are going to talk about part 1. Okay, or AKA the top. Now, you learn to do these. When you start to actually do them, you want to spread them out quite a bit, and you'll have red, white, blue, and pink. Now, when we build these, would they be different toys, a red top versus a white top? Are they different toys? Yes or no? What do you think? To a 5-year-old, the answer would be yes. Okay? Probably to some adult buying them, as your kid's freaking out because they wanted the white one, you go, come on, they're just the same, right? That's why your parents were always lame, right? You're like, you don't get it. You don't get it. I wanted a white one. No. And they're like, suck it up, man. Come on. It's like the only one I could get, right? It matters, right? It does make it a unique toy if it has a red top versus a white top. Then we could have stage 2, which says in the middle, let's do a orange, purple, or black. So you could have orange, purple, black, right? Orange, purple, black. In this one, you could have orange, purple, black. On this one, you can have orange, purple, black. In this one, you could have orange, purple, black. So what I'm trying to say here is that a red top and an orange middle is very different than a red top and a purple middle. Okay? And then we have stage 3, which is the bottom. Okay? You can see these get horribly crushed after a while. But that would be the bottom, could be, I'm going to come all the way over here. The bottom could be yellow or green. Yellow, green, yellow, green. Now, how many toys do I get just the red top? How many toys with red tops can I get? 6, right? Okay, you can see we're going to get 6 for each of these, so you're going to get 24 different toys. Now, a faster way to do that is go stage 1, which is 4, times stage 2, which is 3, times stage 3, which is 2. And you'd get 24 toys. Now, the question would now be, I would pose to you, is how many different toys would there be if you were colorblind? You can't see colors at all. You guys are no fun. What would be the answer if you're playing my game? It would be 1, yes. Kids go, well, that was a different shade than that one. No, it's all the same. Okay, now, so basically when you're doing part 1 and 2 and part 3, you're going to use multiplication. Now, here's a question that I think would be just a good one for even my exam coming up. What if I had 8 multiple choice questions on the exam? And you have no idea what you're doing. Okay? So you're going to guess on every one of them. Now, how many choices do you have for question 1? How many choices? 4. Okay? Now, there's going to be 8 questions on this test. 2, 3, 4, 5, 6, 7, 8. On the second question, how many choices do you have? How many? 4. But what if you answered A on the second one, or on the first one? Would you answer A again? Yeah, why not? Okay. Some people always come out going, oh, there's 3 A's, so I changed the second one to a B. I'm like, why? 3 A's? Hello? Right? I'm just like, okay. So these are called independent. Now, some of you make them dependent, but they are supposed to be independent. You're not supposed to care if the last one was an A. Okay? Now, on question 3, how many choices for number 3? Even if you've had 2 A's already, you still have 4 choices? You guys getting my point here? Okay, so for every question, there is 4 choices. So how many different exams could you come up with? I say, okay, you can do as many exams as you want. You can guess as many times as you want, and I'll give you the best mark. How many times would you have to do it, or what are the most possible times you'd have to do it before you got the one that was 100%? 65,536. But the question that I would pose to you is if there was, say, you could hand in a Scantron, but every time you had it in a Scantron, it was $1. Okay? And if you get 100% by guessing, I'll give you $1 million. Would this be a good investment? Yes, it would be. Okay? Now, if you ever look at Lotto 649, there's 49 choices for every one of them. Okay, you get 6 choices, and there's 49 for everyone. It's actually, most times, if you bought one of every permutation, you would lose money. So if I said, if you can get 100% by guessing, it costs you $1 per one, and if you get it right, I'll give you $40,000. You would go, no, that's not worth it. Okay? But if I was going to give you $1 million, that would be a wise investment. The question you'd have to ask is, did you do 65,536 different ones well? And then you get to learn how these work. Like you would keep the same one as A every time. So maybe do all A's for the first one. Like how are you going to keep that straight? Okay, that would be a couple classes in itself. If I said, okay, this is going to be our little project, and you come up with all of them. Because you'd have to do all A's, and then maybe the next one you'd do B, and the rest all A's. And then C, and the rest all A's. D, and the rest all A's. You got 4 of them done now. Okay? Now, what would you do in the next one? You'd have to do A, B, and the rest all A's. A, C, and the rest all A's. Okay? So you can see it would be an organizational nightmare, especially for some of you that can't even like keep your room straight, right? Now I'm asking you to do 65,000. Okay. Now, the reality is there's always going to be restrictions. And we're going to start getting into some of these. Now, here is one of the most important things you need to know is you always deal with the restrictions first, okay? Now, Eric has been given a lot of questions today, so you will discuss him often. He has been given the task of determining how many odd 4-digit numbers there are in the world. But he has been told, and you'll be told this too on the diploma, and if you're not told this, you have to know it, that 5267 is a 4-digit number. But 0267 is only a 3-digit number, okay? That, when we're talking numbers, 0 does not count as a digit if it's before. It would count, though, if it was a combination lock or something, actually a permutation lock, right? 0 is an actual number on a lock. But when we're talking digits, 0 first is not allowed. So you need to know that going into my test and the diploma. Okay, so I would have that written on a study sheet so you know that. Because if you make that mistake of the diploma or my test, you have no excuses. Okay, so let's first talk about, see how many odd digit numbers there are in the world. Now, odd digit numbers are determined by what? The last digit. The last digit is what makes it odd. I've even had this discussion with people. They're like, no, it's the first digit. I'm like, 5,000. Odd or even? Even. 5 has nothing to do with it. The 0 at the end. So, if it ends in a, what would make it odd? Give me the options. 1, 3, 5, 7, 9. Now, how do you do these? You first, if it's a 4-digit number, you do 4 blanks. This is the way. You're going to need a lot of strategies to do these because some of them, you can't have this as the barrier, right? So always deal with the restrictions first. See, my restriction was, this has to be odd. Okay? Now, the next thing is, let's deal with the first digit. What numbers do I have to choose from? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many choices do I have? I have 9 choices. 1 through 9. On the second digit, how many choices do I have? 10. I have 0 through 9 to pick for that one. How many choices on the next one? 10 again. So you go 9 times 10 times 10 times 5, and you get 4,500. Okay? That's how many odd numbers there are, 4-digit odd numbers there are in the world. Okay. Now, let's go down to here. Determine how many odd 4-digit numbers with no repeating digits. Now, what's the first thing you should always do? Put your blanks down. Okay? So we want to get consistent, especially for those students that really struggle on this unit, because you're going to find a huge variation. I mean, I will, because there's students that just, no matter what, they just get these. I can throw anything at them. They can do it in their head. And there's some students that are like, whoa, okay, so then we go through the steps and then they can get them. Okay? Now, I have to deal with my restrictions first. What are my restrictions? Restrictions are, what are the rules I need to follow to do this thing? Only odd numbers. So this is my first restriction. So I have 1, 3, 5, and 7, and 9. Okay? So I have 5 choices. Now, let's go over here to the first digit. How many choices do I have for the first digit? 9 or 8? 8. Why? I can't have 0. What else can't I have? The last digit, whatever that last digit is. So I only have 8 choices to pick from. Does everybody get that? If the last number was a 7, the first number I cannot pick 0 or 7, or else it'd be repeating. Now here's the fun one. How many do I have for the next choice? It's either 7 or 8, isn't it? Who wants to arm wrestle over it? Who's my strongest 7? Who's my strongest 8? Let's go for it. That's how we'll decide. Okay. What am I not allowed to use? Give me the numbers I'm not allowed to use for this one here. I can't use this, so say the 3, and here I can't use, say, a 6, right? So how many am I allowed? 8. I'm allowed 0 through 9 minus that first and last digit. See, 0 is allowed now. It didn't get to play in the first one, does now. How many for the next one? 7. So 8 times 8 times 7 times 5 is 2,240. Okay, so these are all going to be an exercise in, okay, slow down. Whoa, let me get all my information. And if you miss one little word, you will do it entirely different. Okay, so let's do this one. We have a card number plate in African country consists of a letter other than I or O, followed by 3 digits. The first cannot be a 0, followed by any 2 letters which are not repeated. How many different car license plates could be produced? Now, the first question I would ask is how many blanks are there? How many? 6? 6. I'm with you. 1, 2, 3, 4, 5, 6. Okay? Now, let's talk about the first blank. How many choices do I have for the first? Let's do this first here. How many choices do I have? 2? See, it's any letter other than. What if you thought I'm allowed to use I and O? I guess you're getting that one wrong. Okay? So I am allowed any letter in the alphabet except I or O. Now, you have to know how many letters are in the alphabet. You have to know how many months in a year. You have to know how many days in a year. Everything that you've learned from grade 1 to 12 is on the diploma. Okay? And my exam. So don't go, oh crap, I've been 1 month through grade 3. I still do? What? I thought that was done. Can we move on? So how many letters? Okay, so that one's done. Now how many, so you can either African country, consist of a letter other than I or O, got that one, followed by 3 digits. The first cannot be 0. So let's put that in brackets. Followed by 3 digits. So I'm dealing with this part right now. First one cannot be 0. So how many choices for the first one? 9. Second one? 10. And the third one? 10. Okay? Followed by 2 letters which are not repeated. See? And this would be maybe even a philosophical question, or you could argue this one to death. Does this mean I'm not allowed to repeat that first letter, or is it just saying these two letters are independent of the other one? So we're going to go with the argument that they're independent of the other one. I don't care what the first letter is. Okay? It's just you can put these two letters, but they can't be repeated. So how many choices for the first one? 26 and then 25. And you'll see the answer is the least important of figuring these out. So I'm always going to give you the answer just to speed things up. It's 14,040,000. Okay. Now, let's do some traveling. P, Q, and S stands for Pitland, Queensville, and St. Luke's. Now, question A asks, how many routes are there to go from P to Q? Or, sorry, P to S. So we're going from P to S. How many different ways could I go? Where we got 4. P to S, and you got to go through Q. Got to go through Queensland. 6. Now just watch this. If you're confused right now, I'm just going to go this one here. So I got 1. Start back here. I'm just going to do this one again. 2, and then 3. Or I could do 4. Come back to this one. 5, 6. So the way you should do these is there's 2 ways here and 3 here. So you just go 2 times 3 equals 6. Okay? So now that I've shown you the way, how would you go from P to S through R? How many ways? 3 times 1, which is how many ways? Now, the question that I know would separate into 2 camps, how many ways are there to go from P to S total? Anyone? 9 or 18? Now, you can go from P to S through Q, or you could go from P to S through R. Or is a big word that means this, always. Okay? So you would go 6 plus 3. There's actually 9 different ways. Okay? So, whenever you see an or, it will mean adding. And usually means multiplication. Okay, so we got telephone numbers allocated to subscribers in a rural area consists of 2 of the following. You can have 3 digits, 3, 4, 5, followed by any 3 further digits, or the digit 2 followed by digits 1 through to 5, followed by any 3 digits. Okay? Now, some of you just reading this stuff is going to mess with your head, but you've got to get this organized. Now, we're starting with, now how many digits is each phone number? How about the first one? How many digits is it? 6. 1, 2, 3, 4, 5, 6. Now, the first digits are 3, 4, 5. So how many choices do I have for 3? 1. How many choices for 4? 1, 1. Okay? So that's like the Henry Ford example. You can have any color you want as long as it's black. Okay? You get excited for a second, and they're like, oh, crap. That's just 1. Okay? Now, how many choices for the next digit in your phone number? You get to choose it. You're like there. You're like, I get to pick. How many choices for the first one? So I've done this part. Now I'm doing this one, followed by any 3 digits. 10, 10, 10, right? Or you could have the digit 2 followed by any of the digits 1 through 5 followed by 3 digits. So here you're allowed the digit 2. Here you're allowed any digits 1 through 5. And here, so how many choices do you get for 2? Okay, you can have any choice you want in the world, but your first digit must be 2. How many choices do you get? 1. How many choices for the next one? Okay. How many choices for the next one? 10, 10, 10. So this would be 1,000 plus 5,000 equals 6,000. Oops. Okay. So I got a question for you. Okay, I want everyone to really listen here. So, this is a question that would be asked of you. A hockey game ends, and the score is 6-2. Okay? What are all the possible scores that could have been at the end of the second period? So the game ends 6-2. What are all the possible scores that could have been at the end of the second period? Okay, well, let's talk about, okay, so say this was, I'm going to be very optimistic, say this was the Oilers. This was Calgary. Okay? So, for the Oilers, what are all the possible scores just talk about them right now. What are all the possible goals or scores, they could have had at the end of the second period? 0-6. So how many different options is that? 7. And what about the Flames? 0-2. So how many? So there's 21 different possibilities at the end of the second period. It could have been 0-0, and everything could have happened in the third. But what often people do is they go 6 times 2. Remember, sometimes 0 is an option. Right? It makes sense. It could have been 0-0 at the end of the second period. Okay? I just wanted to go through that one because I wanted people to. Now, Eric still gets more questions, and he gets, how many 4-digit numbers are there if, let's do number 1 first. How many even 4-digit numbers are there? So this one's done right here. So we're doing the even. 2, 4, 6, 0, 2, 4, 6, 8. So there's 5 choices. Now, for the first blank, how many choices do I have? So we do this first, right? How many choices do I have for the first blank? 9 or is it 10? It's 9 because I'm not allowed 0. How many choices for the next? 10. And the next? 10. So 9 times 10 times, there is 4,500. That kind of makes sense, right? There should be as many even as odd. Should be. Okay? Now, let's do C. How many 4-digit even numbers must there be if they cannot be repeated? Okay? So how many options do I have for the end? 5, right? 0, 2, 4, 6, 8. Okay. How much choice do I have for the first one? 8. How many choices for the second one? 8. And how many choices for the next one? 7. Okay, does this make sense? Okay, that's wrong, okay? I want to just ask this one question. What if my last digit is 0? How many choices do I have for the first digit? 9. If my last digit is 2, how many choices do I have for the first digit? 8. So what is the number that's wrecking everything for this one? 0. So you need to do the two cases. You need to do if 0 is the last digit. So let's do or, so that's going to be a plus, if 0 is not the last digit. Okay, so this will be a 1 here, correct? It's got to be a 0. How many choices do I have for the first? 9. See, 0's taken out, right? So I have 9. Now, why do I have 8 before? Well, if it's 2, like this one here, if it's 2 at the end, how many choices do I have for the very first one? I'm not allowed to use 2 or 0, so there'd only be 8 there, right? Okay, let's go back to the first one now. How many choices do I get for the next blank? I'm not allowed to use 0 or that very first number. So how many do I have now? 8 and then 7. Okay, and you'll see this will give the answer 504. Now, let's go back to let's do this one first. How many choices do I have here? How many? 4. And I already did the 8. So let's say the 2 and the 3 are gone. Right? Say the last digit was 2 and the first number is 3. How many choices do I have for the next one? 8 again, right? And then 7. So this will be 1,792. So you just add the two together because it's an OR, right? And that would be 2,296. Okay, so let's say we have the word English. And I have all these letters. And say they're just in like a bag, right? E-N-G-L. They're little Scrabble tiles, okay? Now, when they're little Scrabble tiles, can you have repeats? No, I'm making a word, you guys. If I took out the E, is there another E for me? Can I have all E's? No. Okay? That is with this. They're very distinguishable four-letter arrangements. Now, how many letters am I dealing with here? 7. Okay? So there's 7 letters. So make sure you actually count them. It really sucks when you know what you're doing, but you thought there was 8 there. I think we can assume you'll get the wrong answer. So, if I was to pick words out of a little bag, and I was just to take them in order and put them like that, okay, I have 4 letters. Now, how many choices do I have for the very first letter? There's no restrictions here except no repeating, right? This means no repeating. This is what distinguishable means. Okay? So how many choices do I have for the first letter? 7. Okay, and I put it down. How many choices do I have now going in? 6, 5, and 4. So you have 840 different choices. Now, what if I said the first letter has to be an E? So there's another bag here. How many E's do I have to pick from? 1. I only get one choice. Now, how many choices do I get for the next letter? This was our restriction, right? Now, what do I get for the next? How many choices? 6, 5, 4. Which gives you the answer 120. Now, that almost seems weird. You give me one letter, like say your combination lock, which is a permutation lock. If someone said, and my first digit is a 3, you have decreased their odds greatly of guessing your. If your combination lock, you gave me the first and second combination, how many would I have to try to get into your locker? Think about it. You gave me the first and second. How many different ways would I have to do it before I for sure got it? 60. And it's even less than that because we know as our locks get better or used more, you can be like within 5, right? I remember mine in high school, you just look at it and the thing opened, right? Because it was so. But I like that. You know, you get in there quick. So when you start giving people just one, it went from 840 down to 120 by giving me one letter. Now, 840 different tries takes a long time. 120, that's not as bad, right? You give me 2, and then let's try this one. What if the first and last numbers must be consonants? Consonants. Vowels. What am I talking about? Okay? So the first and last letters must be vowels. So these are my restrictions. How many choices do I have for the first blank? 2. How many for the last? 1. So deal with them first. Now how many choices do I have for the second digit? 5. And then 4. So you'll get 40. That decreases it a lot, yeah? Most people wouldn't say, oh, I'm still not going to be able to guess that. That's impossible. Well, it's not possible. Long and arduous, but not impossible. Okay, last one. The word must contain a G. See how word is in quotes? Because Akuba is not a word, okay? So there are ones that are definitely not going to make, if they don't have vowels in it, it's not going to be a word. So it's just in quotes, okay? So the word must contain a G. How do I pull that one off? Sure, a nice little short question. Must be easy. Must contain a G. No one? Okay, so you're putting the G first. It must contain a G. Does it say G has to be the first letter? So you have this scenario where G must be here, or the G could be here, or the G could be here, or the G could be here, right? So that's how I would visually teach it to show people, okay, I get it, okay? So I got one choice there, and then 6, 5, 4. So with G being first, that's 120. With G being second, third, or fourth, then you just put the 6, 5, 4. And do you see that when we multiply now, you're still going to get 120. 6, 5, and the 4 goes here. That's 120. And 6, 5, and 4. So just do your restriction first on each one, Remember, since they're all ors, you will add them, which gives 480. Okay, so we're doing 1 to 18, and we're going to omit 15. So 1 to 18, omit 15. Okay, you're going to find your solution manual extremely helpful when you go through these. Okay, don't start talking, you guys. Let's go. If you're not going to use this time, then we can get started on the next objective. It'll give us more time at the end of the year.